So welcome again, everyone, and thanks for joining this Secura webinar. My name is Rob Syme. I'm a bioinformatics engineer here at Secura Labs. I'm joined by Harshil Patel, who I'll introduce in a second. Before we begin, I want to go over a couple of small housekeeping items. All questions, when you have them, should be submitted to the Q&A box, which is available via the Zoom panel. We'll go over those questions at the end. There's also be a poll towards the end, so please participate in that. And lastly, we're going to be sharing the recording of this webinar via email, so keep an eye out for that a couple of days after, probably towards the end of the week. As I said before, my name is Rob Syme, I'm a bioinformatics engineer at Secura Labs, and I'm joined here also on the call by Harshil Patel, Head of Scientific Development at Secura Labs. He'll be keeping an eye on any questions in Q&A, and might help out this when we go through the answers at the end. So what we're going to do today is sort of aim for an end-to-end example of taking a Nextflow workflow and running it on cloud using the Tower Cloud. But I want to, before we begin the demo, I want to talk a little bit about Secura, the company, where we're coming from and where we're going. So Nextflow, as some of you might know, is the open source workflow orchestration DSL that has been around for about 10 years. And Secura is the company that spun out to support Nextflow and provide some services and products around Nextflow to support researchers and scientists. Secura, the company, has been around since 2018. At the moment, the customer base is primarily focused in biotech, pharma, and public health. But we also have partnerships with all the major cloud providers, you can see in the bottom right-hand corner. So let's move on to some of the applications of Nextflow and Tower, and why you might want to use this pairing in your own work and to analyze your own data. It'll come as no surprise to anyone here to say that we've seen in recent years a massive uptick in pathogen surveillance. These figures here on the graphs show the growth in SARS-CoV-2 sequencing by the COVID Genomics UK group, who used Nextflow to develop their workflows early on in the pandemic. The portability of Nextflow workflows allowed them to quickly move the analysis close to the point of sequencing, away from sort of like in-house HPC towards close to where the sequencing is actually being done. It was incredible to see how fast this move was performed and how it facilitated really quick turnarounds and this time to first result. There's also examples of Nextflow being used in synthetic biology and biomaterials. Zymergen is using Nextflow, for example, in their biomanufacturing research processes. Very cool work. There are also examples, of course, in direct-to-consumer genetic testings. Here I'm showing 23andMe, who use Nextflow and Tower to run their imputation pipelines at a phenomenal scale on AWS Batch. This figure here is from a great Medium article, linked below, showing the 10,000 concurrent CPUs churning through their data. Personalized medicine is also gaining a lot of traction. This is an example where you might take tumor normal sample pairs to create and detect neoantigens that can be used to create vaccines targeted specifically to those patient tumor cells. And also a topic close to my heart, RNA-seq, sort of using RNA-seq expression to guide plant breeding and programs. So what is Nextflow? Nextflow is a way of managing complex modern software workflows. So here is an example of the EAGER pipeline, an ancient DNA pipeline. Here we have the tube map representation where data is moved from the left, from raw FASTQs and BAM files through these sort of tube map stations. Each of those stations is an example of a process or a tool that performs some action and outputs some new data. And those data, Nextflow takes care of passing along those data from process to process, orchestrating the entire workflow and writing and publishing outputs at the end. The first obstacle a lot of people mention is that what a lot of people face is portability, and this is really fundamental. The abstraction of workflow authoring away from the computer environment allows for the growth of community, and particularly in research and scientists that can start to work together on a set of shared pipelines, even though they might be using vastly different computational resources, like be it HPC or on the cloud. This flexibility also provides any organization flexibility to move their analysis to the data wherever it may lie. And Nextflow is an important part of this because it provides that portability. It can run on any of these diverse computing environments shown in the figure. Nextflow itself has been growing extremely rapidly. This growth is strongly driven by the community, particularly the NF Core community. Obviously, we at Secura have a strong interest in supporting and encouraging this effort. It's hugely useful that the users can take these best-in-class NF Core pipelines and run them directly on Tower, perhaps forking them internally to create a scaffold onto which they can graft their own specific analytical requirements. The NF Core community is, as I said, a really important part of driving this community and adoption. There is Chan Zuckerberg funding for the NF Core community, and it's a really way of deploying, participating, and developing best-in-class pipelines on Nextflow. So we have Secura, the company, NF Core, the open source community, and on top of that, we have Tower. And Tower is a layer on top of Nextflow that adds some extra features that we thought were missing. Nextflow Tower is our commercial offering from Secura. It provides real-time monitoring, also a very quick and easy web interface for checking the status of any in-progress runs, enables you to launch workflows, be it on any of the supported cloud computing platforms or on HPC-style platforms. It also allows you to do important stuff with collaboration, team, and organizational management. We have some extra features that are sort of supplied by Tower, some advanced cloud-native storage that is specifically the Fusion file system at the moment. It also provides some accounting and budgeting tools, so it enables some optimization of runs, parameters, computing resources, and labeling and budgeting, so you can understand exactly how your cloud spend is related to the work you're doing. So I'm going to skip now to a Tower Cloud demo. So what we're going to do today is sort of aim to take an end-to-end example of taking a workflow to Tower Cloud and running it on Tower from scratch. So Nextflow is the free and open source orchestration engine for Tower, free and open source workflow engine. And Nextflow Tower is the Secura commercial product that provides a web front end, an API, and a command line tooling to launch Nextflow runs, monitor those runs, manage infrastructure, and do all that in workspaces that can be shared within your team. Nextflow Tower is available in two flavors, Tower Cloud, which I'm going to show here, but also Tower Enterprise, which can be installed and provided by Secura to your organization, installed within your own infrastructure. But for ease of use, I'm going to show Tower Cloud today, and you can sign up and access everything I'm doing here via cloud.tower.nf or even just tower.nf. I'm going to sign in, and I'm going to sign in using Google. When you're dropped in, when you first log into Nextflow Tower, you're going to be dropped into the community showcase. The community showcase is a space in which we've already set up a lot of infrastructure for you. We've set up a bunch of pipelines, example data sets, credentials, and compute environments that allow you to get going and starting to run Nextflow pipelines immediately. Note, however, that all of these pipelines are running on Secura's infrastructure and inside of our own, in this case, AWS or GCP infrastructure. For the full-fat, sort of full-featured experience of running a Nextflow Tower, what you're going to want to do is actually create your own organization and your own workspaces, which allow you to run your own Nextflow workflows inside infrastructure that you can control. So, for example, inside of your own AWS, GCP, or Azure account. So let's go through what that might look like. I'm going to move from here to organizations. You can see I'm already a part of a bunch of organizations, but I'm going to create a new one. I'm going to create, let's say I have my own lab, and it's called Rob Lab. I can enter some basic information, things like the name, a human readable name, a description. I can optionally give it a URL. Let's grab a logo here and add. So now I have my new Nextflow Tower organization called Rob Lab with this nice name, demonstration organization. So inside of this organization, I can create workspaces and manage members, participants inside of that workspace. So I'm going to add my colleague Harshal Patel. I'm going to add him by just popping in his email there. He's going to be added as a member of my RobLab organization. I can also start to organize teams. For example, I can make a team called Scientific Development. I might want to add members of the team. And I can now have a team that I can use to assign into a workspace. Now that I've got a sort of empty organization, what I really want is a workspace in which I can organize my work. These workspaces are really fundamental, a fundamental part of understanding how Tower works. Everything within a workspace is shared by participants of that workspace, be that runs, launchpad, credentials, and compute environments. So I'm going to run a demo workspace. I'm going to call it Tower Cloud Demo. And these workspaces, you're free to organize these workspaces however you'd like. You might, for example, have a workspace for your oncology department and a different workspace for a different research area. Or perhaps you would like to organize your workspaces into production, development, staging. All those are completely valid ways of organizing workspaces in Tower. I'm going to make it a shared workspace so that everyone can see it inside of my organization. And here I have the Tower Cloud Demo workspace inside of the RobLab organization. As I said, within an organization, everything is shared, and that includes things like compute environments, runs, and launchpad. The first thing I really need to do is add some credentials. I want to use this workspace to launch some resources on the cloud. So I'm going to need to supply some Tower Cloud credentials. And to do that, I'm going to have to put in an access and secret key. So for example, I'm not going to do it on stream, but this is what it would look like. I would give it a name, ask which provider I would like to add credentials for. Note that you can supply credentials for any of the major cloud providers, but also supply credentials for things like code version control systems, container registries, SSH credentials, or even Tower Agent, which is a command line tool for logging into HPC style systems if you don't feel comfortable supplying SSH keys directly. I would supply my access and secret keys and optionally an assumed role. These credentials are generally quite powerful credentials. And what Tower is going to use those credentials to do is spin up infrastructure, manage infrastructure on your behalf, launch runs, and monitor those runs. Instead of doing it on stream, I'm just going to run a small script. I'm going to use the API to write those credentials in for me. Now that I have the credentials, I can go about creating compute environments. For this demo, I'm going to make an AWS compute environment. I'm going to use the credentials that I've just created. Note that it automatically fills here. I select which region I'd like to use. In this case, I want to operate in Ireland. Because I've supplied those credentials, Tower already knows which buckets I have access to. So we'll do the work of auto completing these bucket names, preventing me from accidentally making typos. And I'm going to enable Wave and Fusion. Wave and Fusion are an important and interesting part of the Secure offering. Fusion is a file system which allows you to mount buckets directly inside of the task working directories. This gives us a couple of advantages. It enables us to do very efficient data transfer to and from blob storage, like AWS S3 buckets, directly to the tasks. It also enables the task to be sort of agnostic as to the data systems they're using. There's no changes required to your Nextflow pipeline, for example, to run using Fusion and Wave. It just looks like, as far as the task is concerned, it looks like a normal file system. I'm also going to enable fast instance storage. So this enables Fusion to use the very fast NVMe disks to cache data on its way to S3. This enables me very fast I/O for the tasks, enables me to get my job done quicker. I'm going to post a link to a secure blog, which outlines some benchmarking that we did, showing the benefits of Fusion on AWS using the NF Core RNA-seq pipeline as a demonstration pipeline. What we found is that not only was it more convenient to use and it manage Fusion, but it also gave us cost savings because tasks completed faster and we didn't have to wait for data to be staged in and staged out of each of these tasks. All of that data transfer happens while the task is running. So here moving back to Tower, I'm in this compute environment creation step, and I have two modes of creating compute environments. If I have my own cloud specialists, or Terraform instances, I will select manual. I could spin those up on my own time with my own processes and just supply the head and compute queues. But I'm a biologist, I'm a bioinformatician, and I do not love spending time managing infrastructure on cloud consoles. So I'm going to ask Tower to do this for me. So I'm going to use Batch Forge, which enables Tower to do all that work for me. I could choose spot or on-demand instances. I'm just going to use on-demand for this demo. I'm going to say 512 max CPUs. I can supply resource labels here. So these resource labels are an important part of the cost accounting that I mentioned earlier in the presentation. So these resource labels are key value pairs that will be attached to every piece of infrastructure that's spun up in this compute environment. This enables me to select multiple compute environments and assign different pipelines to different compute environments, each of which will have their own distinct resource label attached. Then at the end of the month, when I come to my cloud computing bill, I can see a breakdown of exactly what pipelines and which compute environments were attracting the cloud spend. I can also select particular instance types. Because I'm using Fusion, I'm going to select 3 very common families with these D instances, ensure that the very fast NVMe drives are attached. I can also do things like add key pairs to logging in, but I'm not going to worry about that. I'm just going to click add. Oops, I accidentally clicked EBS auto scaling, which I do not need. And see what's happening here is Tower is going out to AWS in this case and reaching out via API calls to do things like create compute environments, create AWS batch compute environments, create AWS batch queues, IAM roles, auto scaling groups, all of that infrastructure for me so that I don't have to manage it. At the end, if I would like to remove this, I can delete the compute environment and Tower is going to do the work of cleaning all of that up for me. So I can provision infrastructure without ever having to log into the cloud console. Great, now that's done and the compute environment is available for me to use. The first thing I'm going to do is add a Nextflow Hello pipeline. In my vanilla Tower Cloud demo workspace, I'm going to add a pipeline. I could give it a description. I could add some labels here. I'm going to select the compute environment that I want to use. In this instance, this workspace only has the one compute environment, the AWS one I just set up. But you can imagine in your computer environments or in your workspaces, you might set up AWS compute environments or GCP or Azure or Slurm compute environments, and you select. So what I'm doing here is I'm binding a workflow to a particular compute environment. And the workflow I want to find is this github.com/Nextflow hello. So this hello workflow is a very simple hello world, and it's a really handy way of testing that the infrastructure I've built is actually configured correctly. Tower has reached out to the repository and pulled the revisions. So the Git tags, Git branch names, because I've selected the computer environment's auto-populated the work directory. And I'm just going to not worry about any of the other parameters. It's a very simple pipeline. It doesn't have any parameters. So I can just click add. So to launch the pipeline, I'll just click launch. And what that's going to do is Tower is going to reach out to AWS, submit a job to the queue, a Nextflow job, which is going to start spinning. And then that Nextflow job is going to submit each of the tasks that comprise that job. While that's happening, I'm just going to double check and see if there are any questions in the chat. Second. Great. I think that looks okay. Caleb has asked, we'll be covering cost management. Yeah, I'll make a special effort to ensure we cover sort of the cost management features of Tower. That's a good question. So while this is running, I can have a look at what's happening here. So here we have the runs page, and this is updated in real time as the run starts and then jobs are submitted and the run completes. This run page includes these command line. So this is what you would run if you were running Nextflow on the command line, exactly the parameters and the invocation that was used. As it starts, the parameters and configuration will fill out, and we'll show that as it starts. Actually, while we're waiting for that to start, I'm going to add another pipeline to the Launchpad. So this Launchpad is a table of pipelines where a pipeline is a workflow repository tied to a particular compute environment. So previously, I tied the Hello World workflow to an AWS compute environment. Let's add another pipeline, and I'm going to use a real bioinformatics pipeline, the NF-Core RNA-seq pipeline. NF-Core, as I mentioned in the introduction, is an open community to collect a curated set of analysis pipelines built using Nextflow. And that is almost an understatement of what the NF-Core community is doing. An important output of the NF-Core community is indeed these pipelines. So here at present, we have 84 pipelines for very common bioinformatics tasks. But the NF-Core community is more than just the pipelines it produces. The NF-Core community also does an amazing job of curating and managing and maintaining almost 1,000 modules of common bioinformatics tools and pieces that can be used and imported using the NF-Core tooling inside of your own workflows. This is a fantastic resource that enables you to quickly generate your own Nextflow pipelines, and means that you don't necessarily have to rely on these NF-Core pipelines if you have particular bespoke research interests. The NF-Core community also maintains this NF-Core tool set, which is used to both build sort of scaffolds for pipelines, import modules, and manage and import sub-workflows, and which are also provided in the same way these modules are by the NF-Core community for importing into your own workflows. So the pipeline I want to look at is probably my favorite NF-Core pipeline, written by Harshil Patel, who's on the call, the NF-Core RNA-seq pipeline. Here we have a sort of tube map representation of the NF-Core RNA-seq pipeline. It takes a FASTQ file and produces in a multi-QC report. I get to select which alignment options I like. I can select star, HiSat2, or salmon. I can also select my quantification options, either pseudo counts via salmon or RSEM. This page includes a great deal of documentation about what's required to run the pipeline, but I'm not going to go through all of that here. All I'm interested in here is importing it into Tower. And the only thing I need is this URL, this Git URL. So I'm going to take that back to Tower, add a new pipeline to the Launchpad, give it a name. I know I'm going to configure this to run on yeast data. So I'm going to add a label. This NF-core RNA-seq pipeline can run on, is agnostic as to the particular organism that's being aligned against. But in this case, I'm going to use yeast. So I'm going to add that label here. I'm going to select the computer environment that I want to use and the pipeline I want to launch. I'm just going to copy and paste that Git URL from GitHub. So Nextflow is going to go out, Tower is going to go out and pull all of the versions, the Git tags, the Git revisions. The latest version is 3.12.0. It's also gone out for me and fetched the Nextflow profiles from the workflow repository. So I'm going to use the test profile, which enables the NF-core RNA-seq pipeline to run on a small test data set, very modestly sized, perfect for testing to ensure that the computer environment that I've set up is running correctly. I'm also going to supply a small parameter file. So I'm going to say, specify the out directory to be this S3 path. So this is a parameter that would be, if you're running on the Nextflow on the command line, would be supplied by a --out dir. But here I'm supplying it by Tower in this YAML style configuration. Again, I can add resource labels to attach labels that will be reflected back into the cost accounting, in this case, the AWS Cost Explorer. So I could either supply those resource labels at the computer environment level or at the pipeline level. I'm going to launch that RNA-seq pipeline. And I'm going to leave. This is the parameter selection. So the NF-core pipeline includes a Nextflow schema.json file inside of the workflow repository. If you're authoring your own workflows, I would strongly recommend having a look at this Nextflow schema.json. Harshil, if it's possible, can you supply a link to the best practices blog post describing how that Nextflow schema.json is produced, and or the bite-sized talk about the Nextflow schema.json. This file is then rendered by Tower in this parameter selection screen, where it gives us the option to have a nice UI for selecting parameters. For example, I could switch UMI on or off, or select the aligner that I would like to use. I'm going to use star salmon. And I'm just going to click launch. As before, it's going to go away and submit those jobs to AWS Batch. And I can see here that the Hello World pipeline that I submitted earlier has finished and has been successful with this green tick. I can see the command line that was used, the resolve parameters. In this case, there were no parameters supplied, the configuration. And these two screens, this parameters and configuration, are fundamental for understanding provenance tracking in your workflows. So anyone who has access to this runs page has access to the parameters and configuration. These can also be pulled via the API or the TW command line client for extra provenance tracking. We have an overview of the status of each of the tasks. We have some aggregate statistics of how long the runs took, the utilization, and the tasks. I'm going to drill down to these tasks a little bit more in the NF-core RNA-seq run. In this workflow, in this workspace, I have myself added as a participant, but I'm also going to add Harshil as a participant. And I get to select what sort of role he would have in this organization. And when you're managing participants in a workspace, they can be either owner or admin, these power users, and these top three, owner, admin, and maintenance users, or they can be a launchpad user, either having launch or view privileges. Owners, admins, and maintenance users can do almost everything inside of a workspace. Things like adding credentials, creating and deleting compute environments, and adding pipelines to the launchpad. These launchpad these launch users can do a subset of those tasks, specifically launching a run from the Launchpad and viewing the results. And a view user is limited to just viewing results of runs that have been submitted by one of these other 4 users. So I'm going to add Harshiel as a main admin to this workspace. And that means that he can now launch, if he would like, an RNA-seq run. I'm just going to wait for that RNA-seq run to start and have a quick look at the questions in the chat. I think most of the questions we'll get to in the Q&A at the end. Yeah, perfect. Yeah, we'll tackle most of those questions at the end. One of the questions I saw was one about cost management. So while this run is happening inside of my Tower Cloud demo, I'm going to quickly switch over to a different organization and a different workspace. I'm going to tell a story of two runs. So here we have 2 runs. 2 runs. They're the same workflow. This is both of these runs are an NF Core viral recon using the same full-sized test data set. They both have 1,000 tasks. And in this first version of the workflow, and it's this first run, we've done no work to optimize this run at all. You can see here the task table. So this task table allows us to drill down into specific tasks. I can see, for example, exactly what command line was run to generate the results, when things were submitted. I can see how many CPUs were requested to run this task and how much memory was required. But I also see how much memory was actually used and how much CPU is actually used. When a Nextflow task is submitted to, in this case, AWS batch, we have to request a certain amount of resources for that task. In this case, 2 CPUs and 12 gigs of RAM. As the task is running, Nextflow is monitoring exactly how much CPU and RAM are actually being used by the task. We also measure some ancillary information like how much data is written. But the important things for us today are these CPU and memory. This enables me after the run to see exactly how much CPU is used by each of the tasks. I might choose to view this by percentage allocated. So I can see, for example, that the tasks, the Guppy tasks, are using a very small fraction of the CPU that was requested by the task. So in this case, these tasks and these processes are being over-provisioned. I'm requesting too many resources given what is actually being used by the task. That means that I'm overspending on my cloud compute bill. So I can go from here and identify those processes that are ripe for optimization or sort of trimming the fat on those tasks and modify those resource requests manually. This can be a little bit of a pain though. So Nextflow Tower, because it has a lot of information, can do a lot of that hard work for you. I can click this optimizations available button. And here I have a Nextflow configuration that I can copy and paste into my Nextflow workflow, or perhaps copy and paste into the parameters or configuration field in the run on the Launchpad, the pipeline on the Launchpad. And this will ensure that next time I run this workflow, only these resources will be used, which much more closely matches the resources that are actually used by the task. I could relaunch this and just simply click this optimize button if I wanted to run using the same data set. And that will apply those optimizations automatically. The second thing we might want to do to optimize this workflow is run on the Fusion file system. In a traditional Nextflow task, before any work can be done, the input data needs to be staged into the task. Generally, this is sort of copying from blob storage, all of the input data, reference data, things like that into a single working directory. Then the task runs, and then the output data is staged back out to the working directory. So you'll The time where your VM is actually doing work is bookended by these static times of moving data in and out. The Fusion file system enables you to stream the data in as it's requested by the task. So when the task starts, CPU cycles start to spin up and you begin the work. And as the work is being doing, data is being streamed in from S3 to the task. And similarly, on the other side, if you sort of like scratch false by a Nextflow configuration, you can stream the data back out to S3. So there's large periods in a traditional Nextflow task where simply the VM waiting for data to be moved in or out shrink to zero, and your task runs more efficiently. So we can stack these optimizations on top of each other. So this is the unoptimized version. The 1,000 tasks took 1 hour and 50 minutes and cost an estimated $6.65. If we stack all of the optimizations that are available via Tower, those same 1,000 tasks in exactly the same data set now take only 33 minutes and cost only 55 cents. So we've had a dramatic reduction in the cost required to run this viral recon pipeline. And of course, those same optimization options are available for you running your own workflows. It doesn't have to be an Enercore workflow. Any Nextflow workflow run via Tower can be optimized using Tower. Let's switch back now to my Rob Lab workspace just to check the progress of those runs. And I can see here that Harshil has submitted his own run. So now this one workspace, this Tower Cloud demo workspace that I've invited him to, both of us can submit runs. We can also see the status of each other's runs, and we can also see the results of any of these runs. You'll notice that this page is updating in real time as jobs are submitted, moved to running, and then to succeeded. I'm going to go back to this showcase because there's an important thing that I want to show on a completed RNA-seq run, because our example runs are still in progress. An important part of any run is viewing the results of a run. As I said before, Tower is like a pane of glass into your own infrastructure. Generally, Tower doesn't have access to all of your data, but you as a workflow author, or as the person defining the workflow, can select a subset of the outputs of any workflow to be published by a Tower. The common things this is used for are sort of small, moderately sized data sets, things like these PDFs. In this case, the RNA-seq pipeline shows a PDF showing a principal component analysis, showing the relatedness of samples, or maybe a TSV or a CSV, or an HTML file. A very common output for Nextflow workflows is a multi-QC report, which is a lovely way of aggregating together summary results from lots of different bioinformatics tools. Because this multi-QC report is defined as a Tower report, I can view it directly in here. Note here that I'm just pulling it directly from blob storage, in this case from Google. If you have downstream tools that are expecting those files to be inside of blob storage, they're still there. This Tower is just a pane of glass pulling these reports and making them available via the web UI. Lastly, I wanted to talk about the automation story. So everything I've done via the UI here is also available via the API and the CLI. So the Tower API here in the documentation is exposed via an open API standard. I can view the endpoints for the API. So if I would like to do things like manage users, launch runs, add pipelines to the launchpad, monitor the progress of runs, I can do that via the API with my own internal tooling. For example, if I'd like to hook up my machines that are dumping output data or sort of input data ready to be analyzed to a particular location, I can set up automation to begin runs via Tower. Tower also has a CLI, which enables you to do everything I've shown here via the UI, via the command line. As an example, all I need to do is export a couple of environment variables. I grab the Tower access token from Tower, which I've redacted here. I supply the Tower workspace ID, and I can do things like launch pipeline. So I could run that. Oh. Of course. I forgot to export the environment variable. Great. So I've run a short 3-line piece of bash, and that has submitted a new run to Tower Cloud. So here I've specified the NF-core RNA-seq pipeline, which corresponds to the pipeline that I've set up in the Launchpad. I don't necessarily have to run launches that are pre-configured on the Launchpad. I could just pull out, for example, the Sarac pipeline. I'm going to modify the parameters just a little bit and run that. Wait for the response from Tower. And that's been submitted. If I switch back to the runs page, I can see here all of the runs. My Hello World run, the RNA-seq run that I ran from the Launchpad, the RNA-seq run that Harshil ran, a run submitted by the command line, pulling a pipeline from the Launchpad, and the Sarac run where I've just specified a workflow from the GitHub repository directly. We also have some important data sets feature. So for example, a lot of the Nextflow pipelines use as input a sample sheet, like a semi-structured CSV or a TSV. Rather than having to upload these to some blob storage system, I can use Tower to very quickly and easily manage those small data sets for me. So I can, let's say I've got a small RNA-seq test data set. I can just drag and drop it from my computer, specify that the first row is a header. So this small data set is a really modest sample sheet. It contains metadata like the sample ID, then the paths to those inputs data sets, and some metadata, things like strandedness in this case. I can add that to a data set. I can version these. I can have different versions. And then when I run for the Launchpad, let's launch RNA-seq, but instead of the default input data set, I am going to use this RNA-seq small, the data set I've just set up in Tower. Perfect. So that's now running and will be submitted. So thank you again for coming, and I will see you on a next Secura event in the future.